Oh shoot, I forgot to put that in. All right, so here we are, Bell Work 5. Today is Friday, woohoo! And we're looking at a Cheerios box, which is a rectangular prism, okay? Rectangular prism, which means it has a rectangle as its base at the top and at the bottom. So it says, how many planes of symmetry do I have for this cereal box? So in other words, here's my plane. Remember, the plane goes out infinitely. Where could I cut this so it's going to look the same on both sides? How many cuts can I make in it? Two? Two. Anybody else? 3, 1, 4. Is everybody saying 2? 5. 2, 5. Okay. Anybody else? Okay, well, maybe more importantly, where are they? Where are they? Where are these planes of symmetry? Now remember, we wanted to look exactly the same, like a mirror image on either side of that plane. 2 on the top. Okay, so like 1 here, right? And that would kind of slice it here. Okay, so we're saying here's the long skinny. Now this is not my cereal box, but 1 this way, right? That's going to look the same, both sides. And then he's saying 1 this way, right? That's going to look the same. So we got 1 there, and we got 1 here. Okay. What about those that said 5? Where else? Yeah.
Well, I actually now say 9.
9. Wow. Okay.
Like cut it in half horizontally.
Horizontally. Okay. I'm with you there. So let's see here. Horizontally would be like right here. The top is going to look just like the bottom, right? Okay. Now where?
I also did it from like the corners, like.
Right here?
Yeah, and then the other way as well.
Okay, now let's take a look at this. When you look at this side of it, just look at this side. Does this side mirror it?
Oh, it has to be like mirrored.
Yeah. I mean, we've got a short side here and then a long side. Do I have a short side going over here up to a long side? No. Okay, so that is not a plane of symmetry. Okay. So does everybody see where we have the 3? So we have 2 on the top. And 5 I think is too much. 9 is too much. So the correct answer actually is 3 planes of symmetry. 3 planes of symmetry. 1 across the top, 1 going the other way on the top, and then 1 halfway through the middle. Okay? All right, number 2. We started talking about these cross sections. We didn't really talk about all the possible shapes because we're going to finish that up. But it says identify the shape of the intersection of the cone and the plane in the picture. So we're talking about what is this shape right there that I just kind of blackened. What is that shape? Say it again. Oval. Okay. Anybody else? Circle? Maybe. Okay. Well, take a look. I actually have this, or I should say the math department does. Here's my big cone right here. Okay, here is a plane going through it. And you're right, it does look like an oval, but you know what? We don't call them, unfortunately, ovals in math. We have to make it a little bit more difficult. We call this what?
Slanted circle.
It is kind of a slanted circle, but we don't call it a slanted circle in math. We call it an ellipse. Ellipse. Okay? So write down ellipse there. ELLIPSE, which is kind of like an oval, but the mathematical term is ellipse. Okay, so we are going to finish up talking about these cross sections and the shape that we see from the cross sections. And then we're going to get into these solids of revolution, okay? So let's turn to page 31 in your packets. 31, please. Packets. Just a reminder, we're going to have a test. Would be a week from this coming Tuesday. So after we're done today, we'll have 2 more sections. We're going to do volume of different kinds of prisms, cones, spheres. Then we'll do 2 days of review and a test. A week from Tuesday. Okay. Here we go. All right. So cross sections. I think we are on the bottom of page 31. Should be example 2. Says, identify the shape of each cross section of the cone. Okay? So the intersection of the cone and a plane parallel to the base of the cone. Okay? Am I right? Is that page 31? No? What page is it? 21. So sorry. So sorry. So 21 through 24, I guess. Maybe. '21 through 24. All right. So if I have. All right, it says the cross section, here's a cone. The clear part is the cone, right? It says, what does the intersection when a plane parallel? Parallel means it's not going to intersect it. Parallel to this base right here on the bottom intersects the cone. So if I were to take a slice in here, okay, if I were to cut straight through this, horizontally, what is the shape of that intersection going to be?
Is that what the shape of the green?
Not the green thing. It's a cross section of a plane parallel to this bottom. First of all, look at the bottom. What shape is that? Circle. So if I take a plane that's parallel to this, it's not going to touch it, and I want to cut or take out a piece in here.